Hello everyone, I'm Christina and welcome to video 7 of our A-level mathematics calculus series. In this video, we're still looking at differentiating trig functions from first principles. This is part 2, and our objectives here are just to continue differentiating simple trigonometric functions from first principles. We're going to continue using our small angle approximation, specifically to find the derivative of cos x in this video. So let's find the derivative of cos x from first principles. So we know that our f of x is cos of x. Let's write down our expression for f dash x, the derivative from first principles. That's the limit as h tends to 0 of f of x plus h minus f of x all over h. So we have our f of x, that's just cos x, and now we also want our f of x plus h. So to find f of x plus h, we want to substitute in x plus h into our function f of x here. So what we're actually looking to find is cos of x plus h. Now, recall from our trig series the compound angle formula for cos. So cos of a plus b is equal to cos of a, cos of b minus sine of a, sine b. So we're using our cos compound angle formula here to rewrite cos of x plus h as cos x cos h minus sine x sine h. So now our cos x plus h is our f of x plus h. So let's use this expression for our derivative. So f dash x, our derivative, equal to the limit as h tends to 0 of f of x plus h, which is our cos x cos h minus sine x sine h expression that we found here using our compound angle formula. And I will just label that this is in fact f of x plus h minus f of x, which is just our cos x, all over h. Now, from the previous video, recall our small angle approximations. So for sine of h, which we have right here, sine of h for very small angles of h approximates to h. That's for h. We write that as h much smaller than 1. As h is tending to 0, we can apply our small angle approximation here for sine h, and we can do the same for cos of h. So cos of h tends to 1, or approximates to 1, as h gets very, very small. So let's rewrite the line above, the expression we have there for f dash of x, using our small angle approximations. So f dash x, as h tends to 0, becomes cos x remains, but our cos of h becomes 1, so that's just cos x times 1, minus sine of x, that stays the same, and then sine of h, that becomes h, so let's put that in front, and then minus cos x, that stays the same, so we're at that minus cos x, all over h. So we can see here that cos x times 1, that's just cos x, and that is cancelled from minusing cos x in the last term there. And so what's left is minus h sine x over h, and we can cancel out the h, and we're left with minus sine of x for f dash of x. So to summarize that, for our function f of x equal to cos of x, the derivative of cos of x, f dash x, is equal to minus sine x. And we've shown that from first principles.